Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. This video and the others in the Chapter 5 Problem Solving with Python playlist are an introduction to the concepts you will need to write programs with functions. Other names for functions or similar constructs are modules, methods, procedures, or routines. This video accompanies Problem Solving with Python Chapter 5, but it's okay if you don't have the book. The videos stand alone as instruction on these topics. In this video, we're going to introduce the idea of functions, and we're going to show how to write and call or invoke a simple function. We'll talk about how functions alter the flow of control in a program. Let's dive in. Suppose you want to write a text adventure game. If you've never seen a text adventure game, you can find many examples on the internet, such as this example of the classic game Zork on classicreload.com. A text adventure game is like a non-text adventure game, such as Legend of Zelda, but entirely in text, so everything is described rather than shown graphically. For this game, I have a simple map in mind, with a field bordered by a river, a wood, an unclimbable cliff, and an abandoned settlement. I have open here a first version of the program. We have two variables, location, which is the current location, and choice, which is the user's choice. We print a welcome message with instructions, and then loop until the user chooses Q. The loop starts by printing a description of the current location. It then obtains the user's choice and changes the location based on the user's choice. So, for example, if they've chosen N for north, and they're in either the field or the wood, the new location will be the settlement. If they try to move into the river, then we're telling them they fell in the river and setting choice to Q to end the game. If they type a letter other than a command letter, we'll just come back into the loop and print a description of their current location again and give them another opportunity to give us a command. Now, let me play the game for you quickly. So it says description of field here and then asks for my command. In the description, I would ideally be telling the user that there's a settlement to the north, wood to the east, cliff to the west, and river to the south. I'll type N, and now it says description of settlement. Let me type W. Tells me basically I can't go that way, describes the settlement, and asks for my command. I'll type something that isn't a command. I'll type C. And see, it just describes the settlement and gives me another chance. Let me type S twice and fall in the river to end the game. Okay, now you'll notice I haven't actually described anything. That's going to be a lot of text. Let's write a function to describe each location. Now there are many ways that we could write an adventure program. I'm choosing to use a function here for this purpose because it will allow us to write a very simple function and to discuss some advantages of functions, and it will give us an example so we can discuss how they alter flow of control. So for each place here where I have written description of, and then some location here, I'll have a function call instead. Let me write the function first. I'm going to write the functions under the docstring. A function is a named block of code, and when we use the name of the function, that code executes. We're already using functions in this program. Anything colored purple by IO, at least in the default settings, is a function. So print and input are functions. When we write print or input, some code that has been written somewhere else by another programmer executes. Now we're going to write our own functions. So to do that, I'm going to write def, and you can see that turns orange. That's a Python keyword, and it's short for define, and it means I'm about to define a function. Now the next word will be the name of my function. So this should be meaningful. It should describe what my function does. It should make sense when we invoke the function. This will make more sense with practice, but a good rule of thumb is to use a verb in the name because functions are code and code does something. The rules and conventions for naming a function are the same as for variable names. Letters, numbers, and the underscore don't begin with a number, no other characters, use all lowercase, and separate words with the underscore. So let's call this one print field description. And then open paren, close paren, and then colon. And when I press enter, the insertion point is indented 4 spaces. So anything that's indented under that header, until I don't indent something, is the function body. It's the code that will execute when we use the function name. The first thing I'm going to put here is a docstring. So quote, 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 and then a description of what this function does. Describe the field, including the directions that can be moved, and then quote, quote, quote. And then this function is just going to be some print statements describing the field. So I'll write something in here quickly and come back and read it to you. Okay, so I've printed, you are standing in a field of long grass dotted with wildflowers. To the north, you see what looks like an abandoned settlement. To the east, you see a forest. To the south is a fast-flowing river. It looks dangerous. To the west is an unscalable cliff face. Now, I haven't otherwise changed my program except to define that function. It's sort of like defining a variable. I might write x equals 10, but if I don't then do something with x, it will have no impact on my program. The same with this function. I've defined it, but if I don't call or invoke it, like I'm calling and invoking print and input, then it will have no impact on my program. Let me run the program, and you can see that it's looking the same. You don't see any of the text that I just wrote. I'll quit. However, we can call that function. It is defined. Look at what happens if I type the name of the function and an open parentheses at the console. So print field description, open paren. And notice a little tooltip comes up with some text. It says, describe the field, including the directions that can be moved. Do you recognize that text? And look what happens if I add a close paren and press enter. It executes all of my print statements. So the first really important thing to understand here is that defining a function sort of registers it. It associates the code below the function header with the name, but it doesn't execute that code until you use the name of the function somewhere. Let's look at the syntax of defining the function. You always start with the keyword def for define. You always follow that by the name of the function, and again, the rules are the same as for naming variables. You'll usually name it with a verb. Mine prints a bunch of stuff, so I've used the word print in the name. Then you will always have open and close parentheses. Often you'll have parameters in those parentheses, but we won't talk about parameters until we improve this program in the next video. If you have no parameters, as we have no parameters here, and don't worry if you don't really understand what parameters are yet, then you will need the empty parentheses, and then a colon. In a future video, we will add an annotation between the parentheses and the colon, but for now, we're going to keep it simple. After the colon, the code that is part of the function will be indented. And this is just print statements, but you can put any code in a function that we've learned so far. So you can put in loops and if statements and other functions even. But this is just some print statements. But before that, right under the function header, I've put a docstring. You might recall this came up in the tooltip when we typed the name of the function and the open parentheses. That only happens if we put this in as I've done here, as a docstring under the function header. This is the proper way to document a function. Now, once we've defined a function, we can invoke it by using its name followed by parentheses as I did at the console. We want to invoke this function where I have print description of field here. That's just a placeholder for the actual field description. So I'm going to delete that line of code and replace it with a call to the function print field description, open paren, close paren. And that's it. When we reach this line of code, control will jump up to the function, and once it's completed executing the function code, it will return to exactly where it was called from. Let's run the program first and see that the function is now called. Okay, and immediately you can see that after the welcome message and instructions, I'm seeing the description of the field instead of the text description of field here as we had before. Now, suppose I go north into the settlement and then south again into the field. And again, I get the field description because each time at the start of the loop, we're printing a description of the current location. Now I'll quit by typing Q. And then let's walk through this in the debugger to see the flow of control. I'll go to the debug menu and choose debugger. And then I'll rearrange my windows and return. Okay, now we can see everything. Let's put a breakpoint at the beginning of the if statement that prints a description. Once we're in the loop, and I'll run the program and press the go button so we execute until the breakpoint. You can see that the program has printed the welcome message and the instructions. We can see that the location variable does reference field, so this test should evaluate to true and will go into the conditional code print field description. I'll press over. Okay, now this is the call to the function. Now in the debugger, we usually press over so we don't jump into functions that we haven't written. That can be really confusing, especially for a person just learning programming. But we wrote print field description, so let's press step. This is sometimes called step into in other debuggers. And notice that we jumped to the first line of print field description. We can press over for each line in this function until we reach the last indented line, the last print statement in the function. And now when we press over here, we jump back to the first line after the if statement. So this is the first line that executes after the call to print field description, because it's the first line after the if statement. So we go back to where we called the function and continue executing code sequentially. Now, this is just an introduction to functions. There's a lot more to them, and they can be a lot more useful than this. But even here, let's talk about the advantages to writing a function to print the field description. You can imagine that we would want to have two more functions here, one to describe the wood or forest, and one to describe the settlement, and we'd want to call them in this if statement as we're calling print field description. So the first advantage is that the functions make this code easier to read. Imagine if I had all 5 lines of code here in the if statement, and then 5 more lines for each of the other descriptions. If the descriptions were longer, it would be even more code. Here's what that would look like. You can see that in this version, without any functions, the code for the if statement is quite long, and it's harder to see the structure, harder to see the if, elif, and the conditions, and the main code gets much longer. If we can keep code short so we can see the structure of the code, that helps us read the code and understand how it executes its flow of control. Now let me show you a version in which I've written 3 functions, one to print each of these descriptions. It would be great practice for you if you paused the video now and tried to write them yourself before I do it. Okay, I hope you tried to write these based on the model of the print field description we previously wrote. So now my code looks like if location equals field, print field description, elif location equals wood, print wood description, elif location equals settlement, print settlement description. You can see how easy that is to read, almost like natural language. If you write good names for your functions, they can make your code more readable. And finally, if we were going to print these descriptions from multiple places in our program, putting them in a function is a big advantage because we only have to write that code once. You really don't ever want to be duplicating code. You should always try to find a way to write code only once. Sometimes that means putting code in a loop if it's going to be repeated over and over at the same time, but often it means putting the code in a function so it can be called from many different places at many different times during program execution. We don't need to call our description code from multiple places in this short program, but you can imagine if there were a telescope feature or a crystal ball or a map, something that let you see different parts of the terrain, you might want to call the description functions in the code implementing that feature as well. You would never want to copy-paste that in your program in case the descriptions needed to be changed, because you might not remember to change them in all places. Okay, so that's an introduction to functions, and in the next few videos we'll go over more features of functions that make them much more useful. Functions are a critical component of all software paradigms, so it is very important that you learn them well. I'm going to end this video here, and I urge you to practice with this. Try rewriting this program from scratch. If you're feeling adventurous, add another location and write its description as a function. I've included an auto-graded exercise in the description of this video so you can practice with the video code. Once you've mastered the concepts here, you're ready to move on.